Welcome everyone to the June meeting of the Arctic Observing Systems Subteam. I'm Sally Macfarlane from Department of Energy. I'm one of the co-chairs of the AOSST, along with Will Ambrose, who is here today, and Sandy Starkweather and Craig Chitlook, who unfortunately could not join us today. So our collaboration team focuses on coordination, planning, and synthesis of Arctic observing efforts towards a more integrated U.S. Arctic observing network. We're planning a series of meetings over the next few months or so, possibly going longer than that. We tend to intersperse kind of themed meetings with other meetings, but we're planning a series of meetings on the theme of best practices in Arctic observing. And so for this first meeting, we wanted to focus on the subtopic of environmental sustainability. One of the principles for conducting research in the Arctic that guides IARPC research efforts is to pursue responsible environmental stewardship. And also the 22 to 2026 Arctic Research Plan states that future development of Arctic observing capabilities should consider sustainability in field research and good practices to limit potential environmental impacts. Therefore, we thought it was timely to try to engender more discussion within the IARPC community about aspects of environmental sustainability and stewardship in Arctic observing. Also inspired on this topic by some discussions I had with Matt Shoup about things that were coming out of the MOSAiC expedition. So today we have two presentations. One is by Maddy Smith from the Applied Physics Lab at University of Washington and Amy Macfarlane from the Institute for Snow and Avalanche Research Center. And this is about lessons that have learned from the MOSAiC expedition. And then our second presentation will be by Thorsten Markus, who's the Cryospheric Sciences Program Manager at NASA headquarters. And he'll talk about the use of uncrewed aerial systems for greener Arctic observing. So we'll start with the two presentations, and then we can have some quick clarifying discussions after the first, quick clarifying questions after the first presentation if needed, but we'll save the discussion for the end of the session so we can kind of have a more ongoing discussion. So with that, I will open it to Maddy and Amy.
Thanks a lot, Sally. So I've realized Maddy's sharing her screen, but I'm actually going to start a little differently today. We'll introduce our why we're talking and what actually we're bringing a little later, but I thought we could actually start with a kind of a questionnaire for everyone who's on the call. I've just pasted, yes, exactly. So you can either scan the screens with your phone here, or you can go to the menti.com and use this this link, or use the link in the chat. I believe either of these work. And we're just going to ask a few questions, and basically the idea is to get everyone here thinking about what is sustainability in science, in their perspective, and actually start to I think have these interactive discussions is quite useful at this stage. And then we'll talk about what our group's doing. Is anyone able to access the link, or? Yeah,
no problem. I'm just filling it in right now.
Oh, great. So I think we can share the screen. 1 second. Ah, yes.
Oh, would it be better for me to let you share for a second?
Yeah, I think so. Yeah.
No, it's not coming up on mine. Okay.
There we go. So we're starting to see some of your answers coming in. We've actually done this a few times before, and it's very, very similar answers that we're getting. It's quite commonly the travel plastics and equipment that we are using in the field, energy and materials, things like this. So yeah, I can give a few more minutes, and then there's only 2 questions, so there's one more of these, and then we can move on. And I can also share these later if anyone's interested. Yeah, I always find it extremely interesting what actually comes up in these questions, because I think we always drift towards this this travel, and I think it depends on what type of research you're into, what direction, like if you're in the field a lot, or if you go into conferences. There's a lot of different ways that we can contribute to this to our environmental footprint. For example, like lab work, I know it's very energy intensive. Quite a lot of the time coding, so energy needed for run computers and for servers comes up. So yeah, it's very interesting. Okay, I'm going to move on to the next question. So what are the largest barriers you face when making your science more environmentally responsible? That's interesting. Yeah, so in this question, quite a lot of the time, obviously the time and the money funding comes up. So a different approach to this is the research and development. So actually there isn't the technology in place for us to actually make our fieldwork have a smaller impact, sorry. Yeah, for example, alternatives to fuel, like this is really this research and development that needs to be done. I've never had none, so that's really interesting. I'd be interested to know or hear what sort of fieldwork or research this person is into. Maybe we can do that discussion later. Yeah, so I think I'm going to end that and then move on to our presentation. Thank you, Maddie. Yeah, so as we were introduced, so myself and Maddie were part of the MOSAiC expedition. And if you haven't heard about this already, we basically took the Polarstern, so organized by the Alfred Wegener Institute, all the way to basically the North Pole. But we left the ship to drift with the transpolar drift. And we stayed on the ship for a whole year. And as you can imagine, this size of expedition was absolutely huge. And being an expedition of this size basically means that it doesn't come without an environmental impact. So what's quite interesting about this is that a few of us got together on board and we actually started to have these discussions about what could we actually do to reduce our impact, and also not just on our expedition, but how can we actually change how it's done in the future. So there was a majority early career researchers, but this kind of idea that it comes from a bottom-up approach is quite exciting. So we have quite a lot of motivation to make a difference in future expeditions. So yes, thank you. So before I go into any further details about what the group is doing, I should also mention that, I mean, the expedition of this size definitely took into account some environmental, so the expedition tried to reduce their environmental impact before we actually went. So, for example, I mean, the diesel needed to run the expedition wasn't anything that could be changed. But they tried to do, so they did flight offsetting and did a lot of refuse management and water filtration actually on the ice, so we weren't polluting so much. But yeah, as you can see, like the stats are extremely large about the tons of CO2 that was emitted. And I think one thing that we were just hoping to discuss is that, yeah, substantial efforts were made, but it really raised this idea that, okay, this is something that has a really large impact, and what can we do to reduce that? And I think the idea that, yeah, we have a lot of ideas as to how this can happen, but this group started to form with all of this this energy and motivation. So what are we doing at the moment? We are quite a small group, all originated from people on the expedition, but we have started this community, and we're starting conversations about impacts of science in the polar regions. We're starting with, but we're not just, so we start these conversations, we're doing presentations and going to speak at conferences. We've had a few in the past, and we've got a few coming up. We're also starting collaborations. So, for example, with a French company called Labo 1.5, and we are starting an opinion piece with them. And this is really exciting because it's not just from a polar scientist perspective. So we're really gathering researchers who are from so archaeology, oceanography, this huge range of researchers are coming together, all with the same idea that research and fieldwork, we can reduce the impact. So that's quite an exciting project that we're currently working on. And yeah, finally, it's one of our main topics is actually trying to create an impact report of the MOSAiC expedition. And with the idea in mind that once we actually start to document our impact, we can then advise future expeditions to reduce their impact and also document their impact. So yeah, so that's quite a big project that we've trying to tackle, but it's going quite well. So
yeah, thanks. Sorry, I keep flipping around. Very touchy. Yeah, so when our group started, as Amy was talking about, we started meeting and started by asking ourselves some of the same questions that we asked you to think about at the beginning. And one important question that follows from kind of thinking about these questions is, what does sustainable science look like? And so there's a lot of different approaches. Sustainable science doesn't just mean one thing. And so this slide just gathers a few different examples that kind of we've heard and thought about. On the far right is some images from this project called Climate Sentinels, which maybe some of you have heard about, which is was quite a unique expedition that really focused on minimizing impact of the expedition itself. So they skied across Svalbard to collect data and had carbon offsets for the flights, which are of course unavoidable. But so, you know, sometimes there might be possibilities to do these really low impact expeditions, but also sometimes we need expeditions on icebreakers like we did on MOSAiC. So we should still be doing what we can to minimize the impact of these expeditions. And so this can look like doing our best to make sure that these expeditions are very interdisciplinary with a lot of international collaboration, and ensuring that they're sustainable and that the data is reusable and far-reaching. So kind of giving the most bang for your buck in terms of if you're going to do the science and have the environmental impact, that you're getting the most science out of it. And so, for example, including a wide range of people, like outreach and education, and a lot of different disciplines, which is something that MOSAiC did do quite well. And then, of course, having also strong data archiving and accessibility. Another example kind of in the middle and the top here is the kind of engineering approaches to sustainability. So like we've started moving away from single-use plastics in a lot of aspects of our personal lives, we can consider instrument development with more sustainable materials to be another aspect of sustainable science. And I think some of the things Thorsten will talk about on instrument development might also support more sustainable science activities in this direction as well. So, I mean, I think we can all agree that all of these types of activities can can and should have their place in a more sustainable science community. And so, how do we decide what we want to use and when? And so to make these sorts of decisions, we also need to agree on what sustainable science means. And at the most basic level, I think sustainable science implies the ability to continue into the future. And this is maybe sort of the lowest bar. We don't necessarily see that our current operations are what is limiting our possibility for future work, but our climate is changing and there are still many opportunities to reduce the impact of our science activities. So we've actually kind of started using this term of environmentally responsible science rather than just sustainable science, which I think indicates further that we should aim to minimize the environmental footprint and really maximize our scientific impact. And that this term, environmentally responsible science, also encompasses our social responsibility to minimize our footprint, both for the environment that we work in and for the planet in a larger sense. Yeah, so I think particularly probably why many of you might be here today is that as polar scientists and people who work in polar regions, we do feel obligated to pursue environmentally responsible science and serve as models for the wider community. And I think that that's something that we should be doing and advocating for. Okay, so how do we do this? We're probably, at least mostly all scientists, we know we need data to inform these decisions. So I just want to quickly present this recent study that does this. And so they examined travel to conferences, which has become a really big focus. This came up in our little word cloud earlier. It's become a really big focus in terms of the environmental impact of climate scientists for good reason. And so on that topic, that this study identified actionable changes to conferences that lower emissions and impact. So they looked at where scientists traveling to conferences are coming from, and then examined different scenarios, which you can see in this figure on the right, for the kind of emissions that would be saved from different locations and different scenarios, going down to fully virtual on the bottom. And so then based on this kind of data and study, we can make decisions about, okay, what balances, the most, we might want to have conferences in person sometime. We don't want fully virtual, but what can we do that will still minimize the impact while maximizing the kind of output? And so one of the big things that we are working on and arguing for is that we can take a similarly data-driven approach to reducing field-related impacts. But currently a major challenge to this and reducing our field-related impacts is the lack of data. Quantifying the impact of expeditions and of our science is something that's not yet done. We couldn't find any kind of work along these lines that's been published or documented that's findable online. And so, our polar environments are arguably some of the most sensitive and highly impacted, and the remoteness does result in these necessarily large and impactful field campaigns. So there's a compelling need to quantify and evaluate these impacts. So we've been working on developing a method to quantify the impacts, starting with the MOSAiC expedition. And of course, this is a little bit harder to do in retrospect, but this method that we're developing, we hope can be applied in the future to expeditions prior to them happening and help ultimately inform decisions about what can be done to make the best use of the time aboard and to minimize the impact. So this involves quantification. There's just a quick summary here, but summarizing the kind of global parameters, so like the fuel that the ship is burning, wastewater use of things like helicopters or planes, but then also we're using surveys to quantify the individual contributions to the impact through primarily travel and expendable instruments on the ice. Okay, so just to leave with some takeaways, we as a community are at a point in time, I think, where we have the resources and especially the motivation to make changes, particularly through conversations, starting with conversations like these. But we need more transparency in how we do science to make these changes and improve future expeditions. So I think that implementing impact reports and impact study and more sustainable practices can come kind of from the ground up from our science community, as well as hopefully from some top-down encouragement from funding agencies, et cetera, that might help push these kinds of activities along. Yeah, so we're excited to discuss today after the second presentation. We have some questions that we can share to hopefully stimulate discussion. And so, but also we hope to invite you to also to kind of continue the discussions beyond today. our group formed a MOSAiC, but this topic is not limited at all to one expedition. So our group plans to migrate in the near future to be housed under the umbrella of APEX, but we do plan to be inclusive, not limited to just early career, and inclusive internationally. And so, yeah, looking forward to discussing further. And I'll leave up these discussion questions very briefly while we see if there's any clarifying questions, and then we can move on to the next presentation.
Great, thank you so much, Maddie and Amy. That was really great. And I also appreciated the little survey, interactive survey at the beginning. That's always fun. Are there any quick clarifying questions? Looks like no. Maybe we can, Meredith, well, maybe Maddie or Amy, one of you can put those questions in the chat. If people can be thinking about them a little bit while also paying attention to Thorsten's presentation. So that will be challenging multitasking. Okay, our next presentation is by Thorsten Markus from NASA.
All right, thank you. Let me share my screen. All right, thank you for having me on this session. I think it's a very important topic, and I have been thinking about this and struggling with it in a way ever since I spent time on icebreakers and learning how much fuel these icebreakers burn per hour when they are doing heavy ice ramming is kind of insane. And we are doing it for environmental science. And similarly, if NASA, we do a lot of aircraft surveys, and the fuel amount that these planes burn is like thousands of pounds per hour too. So it's great measurements, but they burn a lot of fuel. So, and with the development of new unmanned vehicles, I am looking into can we change the way we take observations, airborne observations in the future? So, and I will talk about this in general, and then give a little example of what we did last fall for the Arctic. And that is an image from the UAS we flew last fall out of Alaska over the seas, and we'll get into details. So, other than satellites, aircraft really provides the only means for large scale observations. Yeah, that's what it is. And there's, and aircraft have certain advantages. They have a greater coverage than ship or in situ data. You can, compared to space, instruments are cheaper. You can have a range of instruments on an aircraft, radars, radars, radiometers, aerial cameras, stereo cameras, you name it. You can put everything on these large aircraft, and and fly several instruments and get coincident measurements. You can test innovative technologies, new instruments. You can fly instruments that are too high to be on a satellite, and you can also, if you're doing oceanographic or atmospheric measurements, you can also drop sondes from an aircraft and get nice aerial distributions. And on the right, you see the summary of what we flew as part of Operation Icebridge. Operation Icebridge was a 10-year effort to bridge the gap between the ICESat and the ICESat-2 satellite missions. And so we didn't want to be blind with the changing Arctic, with the changing seas, the changing Greenland ice sheet. So we flew aircraft, and we flew lots of them. And of course, we burned also lots and lots of fuel. And some of the data sets we collected were unique. They provided information that we did not have before. For example, the snow radar on Operation Icebridge. It was the first time ever that we had large-scale measurements of snow depth on sea ice. And the thought here was that now with Operation Icebridge ending, how can we continue to monitor snow depth on sea ice? There's no other means than with these low-flying radars, and it becomes environmentally and also complicated, and it's also very costly. So just like self-driving cars in a way, many companies, from startup companies to to companies like Boeing, they are investing big in UAS. And you can tell, like, they are spending millions, on these vehicles, that there's, that's kind of the future. And I think for us, it's really, potentially a path for greener aviation. As I said, some planes, thousands of pounds per hour, UAS are a couple of pounds per hour. It's a couple of orders of magnitude different. And it's also potential for, it's also potential a low-cost alternative for crew aircraft. We at NASA, we have quite a few UAS already, and they range from, at the top, in the center top there, you see the Swift ultra long range endurance aircraft. It's, I forgot what the wingspan is. It's huge, and it flies up in the stratosphere and can be up there like for 30 days. It's mostly solar powered on the wings, and it just takes measurement. It does circles, and you can take lots and lots of measurements. And it goes all the way to the Cicada, which is like a tiny thing that you put out, and I think you drop it from an aircraft, and they're like swarms of instruments where you can take measurements of atmospheric properties, etc. So there's a wide range of UAS available in development and different various stages of maturity to be used from for science, for polar science in particular. So, and I think the next slide is roughly, it's an overview of the instruments on the previous slide, and you can see roughly, what the payload capabilities are, what the costs are, how long, they can fly, and some can just fly half an hour, etc., etc. And those are instruments that are used by the National Park Service, for example, to do surveys. Some are used, as I said, at high altitude to stay up there for a long time. And, operations are, much lower. They're in the thousands of dollars. If we have Operation Icebridge, was roughly, I think, $10 million a year. So it's a lot of money spent on manned aircraft, because you have crew, you have lots of people on the plane. Plane is expensive, fuel costs are expensive. So those are, much less expensive alternatives to manned aircraft. So what we did, I cannot see my slides here really, but that's not right. I think it's all right. So last fall, actually it started like a year or two ago, we tested a specific airplane UAS with a specific instrument to see can this provide, as I said in the beginning, does this have the potential to do continuous snow on sea ice measurements, snow depth on sea ice measurement, because it's something we can't do right now, and no, by no other ways other than drilling holes or putting rulers into the ground, into the snow on sea ice, and I have done this many times. So can we collect, snow depth on sea ice measurements from these UAS? So the platform we used is, it's called, the vanilla aircraft. This has a wingspan of 12 meters, or which is 36 feet. It can stay up in the air, which is really great. It can stay up in the air for 10 days. This is a very long time. And so you have a range of roughly 15,000 miles, which is a huge range. So you can cover a lot of ground with, an aircraft like this, and you have a payload capability of 40 pounds. And what we put onto this, onto this UAS is a radar that was developed by the University of Kansas that measures the snow depth on sea ice. And on the P3 for Icebridge, Operation Icebridge, they used a large version because you have unlimited power, unlimited space, and they made it smaller to fit into the UAS. So on the picture at the bottom left, you see, us, moving the UAS, and the radar itself is in the cone there, and then it has two antennas. And Platform Aerospace, a company who built the UAV, they changed their wings and put the antenna parts underneath the wings, because it would be beneficial to have the antennas further apart than, in the cone of the instrument, in the corner of the plane. So that's another advantage with these UASs. They can put new cables into the wings and hang other things underneath. So they built this cone for us so that we can put our antennas in there. And then the company also added some icing sensors, added some ice shedding coating on the body and on the propeller of the plane, and then did some cold room testing. How did the instrument, how will the instrument perform under Arctic conditions? Because so far, there haven't been really any, long-range measurements on the UAS over the Arctic, because the conditions are harsh. It's very cold, as you all know, and it provides, its unique challenges. So they did a lot of testing, and this is the instrument there. When we tested it at Wallop's flight facility on the eastern shore last late summer to do some test flights, and I think the next one is the next slide. Okay, it's sorry if there's noise. This is from the aircraft taking off on the left side and landing on the right side. It starts on, it's lifted off of the truck, then it goes out. It flies for hours. And then when it lands, it just lands at a little small wheel and then lands. So this is how it works. I don't know whether you had sound or not. My sound was too loud here. Could hardly hear myself. So we tested it at Wallop's flight facility in August or September or so, and then in November. It's November 2021, by the way. Obviously, we flew out of Deadhouse, Alaska, and then flew up over the sea ice. And on the right side, there's a picture of the truck at dawn, for reasons which is interesting because we leave off over land. We have certain FAA regulations to follow, and so they didn't let us fly during night. So they took off, the very beginning of daylight to fly as long as they can. And then on the bottom left side there, you see a picture from the tail camera of the airplane over the sea ice. So what's the outlook here? So the system we tested seems to be well suited to monitor snow depth on sea ice, and it can also measure over glaciers or ice sheets. So I guess there's a potential for mapping snow on sea ice Arctic wide. If this really flies routinely for 10 days or so, or we have 2 aircraft flying. It could be used for monitoring the Northwest Passage on a regular basis, see what the snow depth conditions are there, in addition to the sea ice conditions. And I remember talking with a captain on an icebreaker. He told me that the snow depth is a bigger problem for icebreakers than the ice thickness, because trying to break through heavy snow is trying to break through a mattress. Or we can also map, snow accumulation on Greenland, for example. And then for this type of UAS, there's also other potential application that we are looking into, maybe whether it routinely operationally monitors coastal waters in the Arctic, or even in the outside the US at the Pacific coast or Atlantic coast. You can have large scale surveys of forest conditions, observation of very remote locations. With a 10-day endurance, we could potentially fly, this type of aircraft out of Hobart or Chile and take measurements over Antarctica. And so, but more generally, the wide range of UAS, I think, can provide really unique opportunities to obtain, like with the airplane that we used, it's called mid-altitude long endurance, high resolution data with, with very flexible flight path and observation strategies. How do you, you can design your flight lines, that meets your needs. You can, as I said earlier, you have these, long endurance, high altitude or hail aircraft that, are basically quasi-stationary, which could be a huge advantage for especially the polar regions where geostationary data are not that great. So you would have the possibility to take much higher temporal resolution data. And then you have small UAS, that you can just deploy on short notice. And some people are trying to figure out how to land and have UAS take off of icebreakers and do surveillance and then come back to look what the CS conditions around the icebreaker are. So as I said in the beginning, there are lots of investments happening and there's so much progress in recent years. So I really think there's a potential for much more sustainable observations, especially in the Arctic, because the Arctic or the Antarctic for that matter are great because it's the polar regions, there are no people, which eliminates a big concern for the use of a UAS in general. And if we go to challenges, clearly depending on the size of the UAS, weather and wind are an issue. They are smaller, lighter. Many of them are smaller and lighter than these big manned aircraft. So there is there's some give and take here, and it could it's just they're more sensitive to weather. That's something. It's certainly a challenge. If you want to fly over land, FAA is a big concern. The rules are still not really clear. There are lots of limitations and restrictions. So there's so much development and so much in flux right now. We have to see how this is going to work out and how the regulations for UAS over the United States will evolve over the years. And to some extent, the maturity of many of these UAS is not necessarily sufficient. Some are, but some are not for routine operations. It's not something that you can just, buy and just fly very easily. There's still some fiddling you need to do, some preparations. Obviously, you need, for the bigger ones, you need trained pilots, etc. But, to conclude maybe is, on the right side, you see the example of fuel burn rates and the P3. NASA has one, NSF has one, I believe. NOAA certainly has one. The Navy has one. It's a workhorse when it comes to research planes. It burns, 4,000 to 5,000 pounds per hour. King Air, Twin Otter, 500 to 1,000. And then this little plane that we used, it's not so little, but it has, it fits the instrument, burns 2 pounds per hour. And fuel costs become nothing really anymore, because I think the cost for 24 hours of flights are $240. And compared to, thousands of dollars just for the fuel cost for manned aircraft. Although I realize it's not necessarily a fair comparison, because a plane like a P3 or so has so much more capability. But that's all I wanted to say, really, and just to put a plug in for UAS. Let me stop sharing, and if people have questions, gladly hear them.
Great, thank you very much, Thorsten.
Mm-hmm.
So the discussion, we had the discussion questions that Maddie and Amy put in the chat related to their presentation. And I know Kelly had also put a question in the chat. Kelly, I don't know if you want to ask your question.
Yeah, sure. It was more kind of geared towards any of the other program managers on the call, and how do we kind of start thinking about sustainability in these ways when we're doing just our normal paperwork, such as doing NEPAs and things. And so I'm curious to hear if anybody has started to consider that as they go through the steps of actually funding and allocating.
Yeah,
Go ahead, Sally.
No, I was just going to say that is one topic, kind of thinking more about the regulations that we had thought about having a speaker on for this session, but I think we're going to do it in a few months. But Thorsten, if you had something to add.
No, it's a good question, because Right now, we do nothing, right? This is not a factor. And people just propose taking these measurements. And if a group wrote a proposal to NASA, in my case, and said, we want to take these measurements, but we need a significant amount of money to move our power from generators to, for example, to solar powered and batteries and transportation costs, all these things that are, it would be an interesting discussion to have with the panel, to tell you the truth, right? Because right now, we really don't do much there in our evaluation of proposals, at least.
Yeah, and that perhaps brings up one of the discussion questions that was raised, which was how can we encourage funding agencies to request information about the steps that applicants are taking to reduce their impact? And we do actually have quite a lot of program managers on this call, so I think that's a good question. Don't know if people have thoughts on that.
I'll just add that I recently sat in on the NEPA training on taking environmental justice into account when thinking about NEPA. So I think that this is something we could definitely take step towards. Just have to, I guess, get with the lawyers and and just kind of figure out what we want to start allocating and figuring out. It is a really cool consideration though, and I really appreciate you, Maddie and Amy, for bringing this up. I'm interested in joining the group, and I'll be reaching out. So thanks much.
Yeah, I was really interested in the sort of the survey you guys were putting together and the methodology and trying to actually quantify the impacts, because it seems like that's going to be obviously one of the first steps into being able to even, ask folks what they're doing to reduce their impacts, is knowing what kind of baseline or what methodology. Can you talk more about that, what you're doing there?
Yeah, it's definitely still very much a work in progress because it's hard to get everyone's a reply like afterwards. So definitely would be better to do it beforehand next time. But I mean, I do think one of the big aims is like, yeah, quantifying these different aspects of like, what do we leave on the ice? Like, what is the volume of that? Can we quantify the impact of like leaving those things behind versus like the fuel burn to like, for the transfer vessels, to ice break through to the middle of the Arctic in the middle of winter. And I think quantifying these different components, and it's hard to compare something like leaving plastic behind versus like the fuel you would burn to go recover that one instrument. Like, how do you weigh those things? They're very different. But if we can start to quantify these different components in a way that like we can compare, and like, maybe, for example, there could be some comparison, or maybe one thing that you could say is like, a big way we could have cut down on the emissions of this expedition is to have less legs. Just, there were 6 legs or 5 legs ultimately. If we cut that down in half, I mean, people have to be there longer. So it's, there's trade-offs to everything, but maybe that's a way that you end up cutting your emissions by, a third. So anyways, I think the big goal is having these, for example, like seeing plastic left on the waste, like that's on the ice. That's like a very visual thing that like feels very like visceral and like concerning as a person who cares about these environments, but like, is that actually the thing that we should be concerned about? And I think through like having a methodology and trying to quantify those different components, we can actually start to hopefully understand that. And I mean, none of us are experts in that. So we're coming at it from the experience that we have in the field, and hopefully there will be opportunities in the future to like work together with people who are more experts in that topic.
What I've heard, it's an excellent point, because what I've heard once in the discussion, and I try to remember who that was, is the point was made, the largest environmental impact on all these expeditions are people, because MOSAiC is a good example. You have all these different legs. If you spend more time and take these measurements automatically, you can save so much money and so much reduce environmental impacts dramatically. It's just having people out there is the biggest environmental impact. If you can automate these measurements, it's just an opinion I've heard. I'm trying to remember who that was, and I can't.
Yeah, I think many people can attest that automating Arctic measurements is quite challenging, of course.
Of course. Oh, no, 100%. 100%. I know.
I think, Brian, did you have a question?
A couple questions and a couple comments, and those are excellent presentations. Thank you. As some of you may know, the US EPA is a scientific, regulatory, and enforcement and funding agencies, and involved in many different programs, including the Clean Air Act, which we are mandated to provide funds to the states and others, including coal burning plants, to clean up the air. One of the major programs we've had in the Arctic out of our Anchorage office and also EPA Region 10, it's called black carbon. And it's black carbon coming from the indigenous and other populations burning fuel oil in the Arctic. And we used to have at least a huge, gigantic program with Russia. Because in addition to the tundra fires and use of coal in Russia, it's estimated, and I'd like to check this, that about 40% of the warming in the Arctic may be due to black carbon, which emphasizes the importance of this type of work. So that's one point. The other, having known folks involved with the ice bridge with the P3 Orion, and this is to Thorsten.
Yeah.
Do the satellites that took over that role after the P3 Orion was grounded, were they capable, or did they have sensors for measuring snow?
So, not really, no. We're trying to do, the ISA-2 mission that, replaced Icebridge, if you will. And there's a European mission, and jointly they may be able to measure snow. So there are efforts right now to at least get on a large scale, get snow depth on sea ice measurements. But no, snow depth on sea ice is still one of the major unknowns.
Thank you. And one last comment. Believe it or not, we do oceanography research under NEPA, huge. We're involved for all environments. EPA is involved under NEPA, Clean Air Act, Clean Water Act, Superfund, drinking water, groundwater, whatever. Here in Rhode Island, we have a field program in the coastal zone, Narragansett Bay, Atlantic Ocean, streams, rivers and others. And we have a checklist to leave no anthropogenic waste behind. And that includes when we go out to wetlands or marshes or salt marshes to make sure we have the proper vehicle that will leave the least amount of imprint on the vegetation, for example, including rules of behavior of driving trailers and trucks and boats, and including to make sure we have checklists for non-native species. For example, invasive species. We've had huge problems in an aquatic environment, and this includes estuarine and marine and Great Lakes and rivers and streams. One of the sources of invasive species, which probably happened in Alaska from ships coming from Europe or off of California, is making sure when we bring our boats back, there's a stringent protocol to wash down fairly hot water, the engine, and you folks probably know this already, but to wash it down with soap, and we actually have a formal checklist. And out of my ignorance and perhaps stupidity, I don't know if this type of thing is being done now in the Arctic.
Does anyone want to comment on that? That's a good question about kind of concerns about transporting invasive species or around. I think that's a question beyond our expertise, apparently, Brian, but it's a good one.
But it's a worldwide problem, and I just described what has caused it of it.
Mhm.
What do you think the,
Okay, I think, we only have a few more minutes for
Okay.
questions, so I want to give Will a chance, and then we had a question in the chat as well.
Yeah, thanks, Sally. And thanks to the presenters. That's just really interesting presentations and good discussion. I can't help but think, so one observation and then one question. So I can't help but thinking about the MOSAiC drift as actually having less impact than if the ship were underway, right? You had comparisons of oil burned when it was underway and comparisons of when it was drifting. And there have been very few Arctic drift expeditions. Nansen 1893 is the first. There have been some ice stations, but not many. So that seems like an efficient way to sample that large area of the ocean, with fairly low impact than if you were actually breaking ice the entire time. Now, you'd have to figure out number of days and break and everything. But so that's just an observation. But my question is, how many of these impacts are specific and unique to the Arctic? Certainly breaking ice is, right? That one's obvious. Remote areas, maybe. There are plenty of other remote areas in the ocean which are hard to get to. In fact, some areas that are even harder to get to than many areas of the Arctic. So how much sort of emphasis are we putting in the Arctic because we're Arctic scientists and because climate is impacting the Arctic differentially or disproportionately, as opposed to questions that we should be addressing, across all oceans and all environments? I mean, should the Arctic section just be thinking about this at NSF, or is this a UNOLS issue? Should biological oceanography be thinking about this? What are your thoughts on that?
Can I add something to this? I think as we've been working on the impact assessment, we've really learned so much on the way. And also from the MOSAiC expedition, being in this situation, we realized that it wasn't just as simple as it was kind of laid out. So for example, we had so many, like the ice dynamics was absolutely incredible. So we actually had to use the engines quite a lot during the drift. So things like this kind of play a role in the impact assessment. But what we are really, as Maddie kind of touched on before, is that what we're realizing is the value of doing this before the expedition. So really collecting the data before any steps have been taken. And I think what we can really learn about, from like industrial practices, because impact assessments aren't a new thing. So they're really a common practice in industry. And they get done in the planning stage before the expedition or before the building gets built, and then again afterwards. And I think if we could just encourage one of these steps to be considered before going into the field, to actually do a bit of analysis about what the impact is, then we can actually even go to funding agencies at this stage, and then they have they have all of these applications on the table, all with an impact assessment. And then when they're seeing one sexy new expedition which has a really high impact, or a application funding which is working on existing data but has an extremely low environmental impact, I think this could actually help them balance out these two applications and kind of put a focus on analyzing data that's already there, because I think that this is also like another way that we can reduce our impact in science, is to actually see what's out there already. But that's just my opinion for that. So yeah.
Great, thank you, Amy. Maddie, did you have something to add?
Yeah, I mean, I totally agree with what Amy said, and I guess to Will's question, I really don't see any reason that same approach can't be applied elsewhere. I think, the focus on polar expeditions probably did largely come from the fact that that's where we work, and kind of this idea that those are relatively otherwise, there's a lot less like local inputs, like the ships, these expeditions that we have maybe a more disproportionately high impact on those remote environments. But I mean, similar, and maybe there are some unique challenges related to doing these sorts of impact studies with, ice breaking, for example, being so variable in the amount of fuel burned, et cetera. But there's no reason that we can't apply the same sort of approach, and that we shouldn't apply it to all types of field work, which is some of the kind of conversations that we've had connecting with this group in France who has all kinds of scientists. And so definitely hope that it's something that continues to go in that direction. But as polar scientists, I also hope that we can start to be the kind of beginning of this change in conversation.
Thank you. I want to be aware of the time. We only have sort of a minute left in our hour, and we can continue the discussion if people want to, but I did want to, there was a question for you, Thorsten, in the chat from Claire. She asked, is there a plan set for any long distance flights in the Arctic, or is it too early to say when that would happen? You're on mute.
Yeah, it's a little too early to say. We just tested the system. Are UAS capable of flying, in the Arctic conditions? I'm feeling way more positive now, and so hopefully there will be some. And maybe I reach out to, Sally and Kelly and our NSF friends to work together on something like this, to pull something like this off. Right now, we are just in the exploration stages still.
Great, thank you.
Mm-hmm.
And then one great question I had was whether anyone knew about research that was being done in biofuels for ships or aircraft, because that seems like another possible way to address this. Partly address it, but I don't know if there's, I imagine airplane fuel is pretty special compared to automobile fuel. But.
Yeah, I don't know. It's a good comeback. Yeah, I don't know.
This is Brian Melzian. The U.S. Air Force has actually developed jet fuel because that's a huge vulnerability, especially now and overseas, and it's been quite successful. And I think it's a high enough quality that the Raptor and the other 5th generation jets can use that. And so there's quite a big research effort in the United States to develop biofuels of different types for different uses.
Another area of technology. Okay, it looks like we're starting to lose some folks as we get to the end of the hour. I want to thank our presenters again for really some thought-provoking presentations and discussion. And like I said, this is sort of the first meeting in the theme around best practices. So I think our group might revisit this, but I think it's also given us some thoughts and things to think about within IRPIC and our agencies. And yeah, if you mentioned that the MOSAiC group is going to be transitioning to Apex, if you want to sort of drop us a note when that's kind of more available for folks to join, we can share that information out.
Yeah, we certainly will. Thanks so much for the opportunity to discuss today. It's exciting.
Yeah, thanks so much. Good discussion.
Thanks,
Excellent meeting. Thank you.
Thanks, everybody.